Hello pre-calculus students, and welcome to a video example using sum and difference formulas for trig. And this example is going to be similar to the last one where we're going to have reference triangles. This time the diagrams are given to us rather than information about the diagrams. Well, actually it's a combination, so we have the diagram but we also have a little bit of information. And remember Pythagorean identity, this is x squared plus y squared equals r squared, so that means that for this one r is 2, and for this one, r is 1. And so we can just put those radii into the triangle. Well, we should probably draw the triangles first, huh? So let's just extend this straight down. There's a right angle, hypotenuse 2. Let's extend this one. Remember that the reference triangles always go to the x-axis. They never go to the y-axis. This is the 1 here. Okay, now looking back here, this is our x and our y, so this is going to be, we don't know yet, but we're just going to call it x for a moment, and y is 1. And you could use the Pythagorean theorem, but hopefully you recognize that this is actually a special right triangle, with the shorter leg being half of the hypotenuse in a right triangle. That only happens when it's a 30, 60, 90 triangle. So that means the longer leg is the shorter leg times rad 3, and this is just plain old rad 3. For the other one, we do have to use the Pythagorean theorem, so let's just go ahead and let's fill in what we have here. This is in the fourth quadrant, so the y will be a negative number, but the x is the 1/3, and that's a positive 1/3, and this will be our unknown. We'll figure that out right now. So we have 1/3 squared plus y squared equals 1 squared, and this is 1/9 plus y squared equals 1. Subtract 1/9 from both sides. Y squared is 8/9. Take the square root. Y is positive or negative square root of 8/9. Square root of 8 is 2 rad 2. Square root of 9 is 3. And so this is a, in the fourth quadrant, this is going to be the negative, so this is going to be negative 2 rad 2 over 3. Okay, now that we have the triangles figured out, we're going to use them in a sort of a long, ugly example with the tangent, and then a shorter, easier example with the cosine. So let's first set up the tangent. Okay, so for the tangent, we're looking at the tangent of alpha plus beta, so that's this one, so it's going to be plus in the numerator, minus in the denominator. Okay, so this is going to be the tangent of alpha plus tangent of beta, so we'll have to look at the separate triangles, over 1 minus the product tan alpha tan beta. And let's fill in the numbers for this. So we know that the tangent of alpha, that's not too bad, it's 1 over rad 3. So from this alpha triangle, the opposite over adjacent is 1 over rad 3. So we're looking at 1 over rad 3. Now this is going to get a little bit ugly. Tangent of beta is the, over here, is the, from beta, oh I forgot to put the beta in here. Let me just put that in here so we can kind of keep track of where we're looking. This is the beta triangle. And so the tangent of beta is the opposite over adjacent. So it's negative 2 rad 2 over 3 over 1/3. And that's just the numerator. So this, it'll cancel nicely, well not completely nicely, but it'll get a little bit nicer. So this is negative 2 rad 2 over, let me just go one more time, over 3 divided by 1/3. That's the x, or the adjacent. Yeah. Okay. And that is all over, let me just get back to the black pen here. That's all over 1 minus the product of these two things. So it's 1 minus 1 over rad 3 times that whole thing, negative 2 rad 2 over 3 divided by 1/3. Okay, that's a lot of layers. That's 4 layers of fractions. So let's go ahead and start out by just canceling out these 3's, make it a little bit more easy to look at without getting too intimidated. Now let's just rewrite this one. So this is going to be 1 over rad 3 plus negative, so that's minus 2 rad 2 over 1. So it's going to say minus 2 rad 2. And that's, oh, you can put it over 1. And that's over 1. And now it's subtracting a negative, so this is plus. And this is going to be a 2 rad 2 over rad 3. 2 rad 2 over rad 3. Okay, it's a little bit better. We still need to get a common denominator for each numerator and denominator. So it's going to be rad 3 for both. So this is going to be times rad 3 over itself. And this one over here will be times rad 3 over itself. Okay, so this one becomes 1 minus 2 rad 6. Let's just do it this way. 1 minus 2 rad 6 over rad 3. And then the denominator will be rad 3 plus 2 rad 2 over, luckily, the same denominator, which means we can cancel it. And from 4 layers, now we're down to just 2 layers. Okay, so now we have something that looks kind of like a mastery quiz. We have 1 minus 2 rad 6 over rad 3 plus 2 rad 2. We want to simplify that, so we're going to multiply this by the conjugate of the denominator, which is rad 3 minus 2 rad 2 over itself. Okay, so we're going to multiply those and these. And I'm going to pause it, finish it up, and then hopefully you'll come up with the same answer. Okay, so you could have gotten either one of these for your final answer, 9 rad 3 minus 8 rad 2 over negative 5. And then if you take this one and you pull out a negative from both numerator and denominator, so they would cancel negative ones from both, then they both become opposite. So this would be, everything would change sign. So that's slightly more simplified just because it has fewer negative signs. But I don't really worry too much about that detail, so either one of these would be acceptable. Okay, the other one is luckily much shorter. Tangents tend to be longer, especially when you have 4 layers in your fractions. This time we're going to look at the cosine of alpha minus beta, and we're going to use the same triangles that we've already finished up. And so the formula for the cosine, looking back at the identities, the formula for the cosine is right here, the cosine of alpha minus beta, right? The alpha minus beta, so here it is. So we're looking at this one right here. Okay, so it's cosine plus sine. So it's going to be the cosine of alpha cosine of beta plus the sine alpha sine beta. And we just pull those numbers right off of the triangles above. So the cosine of alpha, we look over to the left triangle, and from alpha it's going to be rad 3 over 2. Cosine of beta, we look over at the right triangle, and it's going to be 1/3 over 1, which is 1/3. Sine of alpha, we look back over at the left triangle, which is 1/2. And the sine of beta, we look back at the right sided triangle, which is going to be negative 2 rad 2 over 3 over 1, which is just negative 2 rad 2 over 3. Much quicker to simplify this. The denominator is 6 for both terms, so we can just put this all over one denominator. Rad 3 times 1 is rad 3. 1 times negative 2 rad 2 is minus 2 rad 2. And there's the short one. Okay, I hope you found this video helpful.